Hello everyone, this is me Arijit with a new video, and in this video we are going to build a face recognition based complete attendance system using deep learning. Now why it's complete attendance system, the reason is here in this project we are going to have one person enrollment system, like person enrollment code I would say, where you can actually enroll any person's picture using a particular code, and like for example you can give him a name and you can actually save his images. And next you are going to have the face recognition based attendance system. So whenever the person will come in front of the camera, the system is going to save his credentials, like save the entry time in the database. And finally we are going to have a Flask app in which you can actually check the attendance. So basically you can so the web page there you can give the date, and then based on that is going to show you that hey, this person was present at that day and this is the time that person has entered, something like that. So that's just a complete system. We are going to have all these things, and this system you can even run in your Raspberry Pi. So it's a deep learning based system, but still it can be run on a Raspberry Pi. Even in Raspberry Pi, you are going to get FPS of like 8 to 9 FPS. And if we talk about real system, like maybe a Mac or a Windows or Linux, so you will get a very good FPS around 25 to 30. And in this video, I'm going to show you both. So how to run in a Raspberry Pi and how to run in a full system like a Mac, Windows or Linux. All the things we are going to cover. So now without wasting any time, let's get started. Okay guys, so let's start with the video. So first, obviously here all the codes we have used in this project you can find in our GitHub repo. The link will be in the description. Okay, now at first here I'm going to tell you what the files basically in the repo will do. Okay, next I'll tell you about little bit about the installation. Then I'll show you how in this Mac you can run it, and similarly with the same procedure you can run it in Linux and Windows. And also I'll show you even in Raspberry Pi how it will run. So I already have connected my Raspberry Pi in BNC. So I'll show you in Raspberry Pi also how it is working. So for Mac, I'm going to use the internal camera of the Mac. But in case of Raspberry Pi, I'm going to use HP W300 webcam. But you can use any other webcam also, no problem in that. Okay. Now let's talk about the files here. Okay. Now, as I already mentioned, here we are going to use deep learning. So here we are going to use a library called dlib. Okay. Now I'll tell you what this library is doing here. So the very first thing is here there are main 4 files. Okay. So one is get faces from camera tikinter, features extraction to CSV, attendance taker, and app.py. Okay. Now get faces from camera tikinter, as the name suggests, it's just going to take the faces as going to save in the computer with the name. Okay, so what it does, so basically whenever you will run this code, what will happen is in the screen you can see it will detect the faces, and then you can actually keep the person's name there and you can save it. So what will happen, this code is going to create a folder and is going to save the person image in that folder. This is it, nothing else. Okay. Oh yeah, another thing is that whenever it will do face detection, it is only going to crop the face. Okay. So this code is not going to capture the whole image, it's going to crop the face from the image, and that cropped part is only it's going to save in the folder. Okay, this is the part it's going to do. And you can actually take multiple pictures of a person, no problem in that. Okay, even if with a single image also it will work, but multiple images will be obviously better. So you can take as many images as you want. Next is feature extraction to CSV. So what will happen that this code is basically capturing the images, the face part, and saving. Now this part, feature extraction part, is going to take those faces, images of those faces, and it's going to save something called as 128D face descriptors. I'll tell you what that is, but for now you can assume that it's kind of an array of it's an array and it has our face features in it. Okay, so for every person there is going to be an array, and in that array the face features will be stored. How we are getting the face features will come later. Okay, finally we have the attendance tracker. This is doing what? This is going to just capture the images, is going to detect the face, and then it's going to, for each face it will detect, is going to find out the same array of features, and then it's going to compare that array of features with all the features previously we have saved. features of different persons, and then based on some distances, so there will be some threshold distance, And then also we are going to compare distances of different persons. So based on that, there is a logic. So based on that, it's going to say that this person has the closest, this person is the closest to this face, and based on that, it is going to match. Finally, we have app.py. Now this app.py is a Flask app. You can run it, and then you can go to the web page and you can check for a very particular date which person is present and at what time that person has entered. Okay, so this is the project structure. In the requirements, we have the requirements like which library is needed, and finally in the templates folder, we have the HTML file, so index.py, which is for the Flask. There is another folder you need, which is not here, which you need to download from this Google Drive link. Okay, so if you go to this Google Drive link, you will see, let me just open it for you. So there is this data. So you need to download this data. Don't download data dlib, download the data. Okay, because this whole data folder you need to paste inside the repo. So inside data folder, you are going to have data dlib. Inside that, you are going to have these two files. One is this shape predictor 68, and then there is a dlib face recognition version 1 or something. Okay, these two files. I'll tell you what these files are doing. But these two files you need to download this data folder. So come here, click here, download as zip, and then you download the repo and you paste this data folder inside the repo. That's it you need to do. Okay. And coming to the required libraries, you don't have a lot of libraries. The dlib, numpy, scikit-images, pandas, OpenCV, Python, Flask. These are all things you need to install. Okay. Now let's just go one by one code, and let me basically tell you what these codes are doing. And then we are going to test that in this system and also in the Raspberry Pi. Okay, I'm not going to tell you every meaning of every line. The main overall concept I'll tell you, and important parts I will explain you. Okay, remaining things mostly stick into stuff, and then there is some general data logging and stuffs. But mainly the deep learning part and the comparison part I'm going to explain. So see, this is, like I said, get faces for camera. So this thing is going to capture the faces from the camera and going to save it. Okay, before I explain the code, let me run the code for you. So you will see the thing, and then finally I will explain again. Okay, so for that I will show you how you can run it in your Mac or Windows or Linux. So I'm going to use PyCharm. It's easy to run in PyCharm, but if you want to use in any other editor, it's fine. You can go for them. Okay. Now in PyCharm, if you want to use PyCharm, in that case, what you have to do, you can just go to, just a minute, let me just do in this way. Okay, fine. You go to file, from there you go to new project setup, preferences for new project, you go to Python interpreter, and from there you need to download the libraries. So for example, if you search for, let's say dlib, it's already downloaded, as you can see. And one thing, remember, dlib takes a lot of time to install. Even in PyCharm, it will at least take, I don't know, 10 to 15 minutes. So when you're installing it, if it seems that it will get hang, but it's not hang actually. Okay, so it will take time. Don't worry, it will get installed, but it will take time. In this way, you can search here and install all the libraries you really need. Okay. Next, let me first. So as you can see, this is the folder. Face recognition, the GitHub repo. Inside that we have basically these files I mentioned to you, and the data folder you need to copy. Okay, so templates you already have it, these files you already have it. Attendance DB you don't have it, but our program will create it of its own. You don't need to create it. The data folder you need to paste, and inside that you have data dlib, and inside that you have these two files. Okay, this landmark one and this REST model version 1. Okay. Now let me run the get faces from the camera file first. So let me run it. So it will take some time. Oh, actually I cannot run it because I'm running this thing. Okay, let me just close it for now. Okay, so now as you can see here, it is detecting my face and it is the face register. So, and as you can see, it is detecting my face properly. And if you see the FPS, it's around 14 to 15. Sorry, it's not 25 to 30 as I said initially. It's 14 to 15 around. But one thing, if you see, when I come too close, it's making it red. So it means that my complete face is not coming, and you will say out of range. So you have to place your face in such a way that it should be white. Next, you can give it a name. So in my case, I'll give Arijit. And if I say input, it's going to create the folder for me. So as you can see, person1 Arijit created. Next, if I save current face, it will save my face. Some few more images I'll just take from here. 4 images I've taken. Next, I will click cross. Now, if we go to, as you can see in the folder, data faces from camera, it has created a folder called person1 Arijit. And inside that, you will see all my faces. Okay, all the images. So now it has captured the images. Now next, there is a file called feature extraction to CSV. Now, like I said, this file is going to create that CSV file where we'll have the array. So let me run it. You just have to run it, and it's going to take the images from this folder and it's going to create the CSV file. Now, if you see feature all CSV, if you open this file, as you can see, Arijit, for Arijit, it has created the array. So this is the 128D descriptor array. Okay, you can say face descriptor array. Now we are done these two steps. Now final step is attendance taker. So I'll just run this file, attendance taker, and if I just run it, just wait for a few seconds, as you can see, and it is detecting Arijit properly. Okay, as you can see, it's detecting Arijit. Okay, so now I'm going to actually basically going to enroll another phase to just show you. So here we need to again run the get faces from the camera code. So I'll just run this code. So here, and I don't have any other person here, so I'm going to use my phone and I'm just open some images. So here I'll use Shah Rukh Khan image. Shah Rukh Khan is an Indian actor. So now I'll just give it a name is RK, and I'll just create the input. So it has been created. Now I'll just save the current face. So current face has been saved. Now let me just take some other images of him. You can see this is another image of him. Save the current face. Done. Maybe another image. Okay, I'll take it. So as these are like basically images from phones, it's hard to get the features in this way, but yeah, still it will work. So I have just taken 4 images, and now I'll just close it. And now what I'll do is I'll just again run the feature extraction code. Yeah, feature extraction code I'll run. So it's done. Now I'll run the attendance taker code. So run the attendance taker. So as you can see, for me, it's detecting Arijit. It's fine. And now let me open my phone and see if it can recognize SRK. So it's correctly saying, yeah, as you can see, it's saying SRK. I don't know if you can see it in the screen, but it's saying SRK in yellow. Now let's just take some other image. This is a complete new image. This image I haven't trained. Let us see if it's working. Yes, as you can see, it's saying SRK. And for me, Arijit is for this one is SRK. So as you can see, it is taking some time to recognize, but yeah, it's saying SRK, as you can see. Okay, so in this way, this is going to work. And now finally, let me show you the app. Basically the app.py, which is going to create the Flask, going to open the Flask web page for us. So now it is running. I'll open it. This is the attendance tracker. I'll just open the date. So it's 5, show attendance. As you can see, Arijit 214. So for the very first time, it has encountered my image as 214 and SRK image after me 218. So as you can see, with the time, it is going to show us the time and also the name. And also it is going to show us the time of the first occurrence, not every occurrence. Okay, so this is how the whole project is working. Okay, now now let me just go back in the GitHub and I'll explain you the code. Okay, now let's start with the get faces from camera detector. Okay, so here we are using dlib.get frontal face detector. Now this thing basically detects faces. So this is responsible for detecting the face. Next here, just that some detector stuff. We are making the windows, we are giving it names, we are making the levels. Nothing that important. You can change the things if you want. Here we have important thing, video capture 0. So from here it is getting the frames. So as I am using my internal webcam, I am giving 0. If you have you want to use external webcam, you can give it the number here. Next, GUI clear data. So this is basically going to clear the previously available data. So there is a button using which you can clear it. So for that thing, input name is just creating the folder. GUI info, again the buttons and all the stuff. So here there are many three things. There is a button to clear the data, there is a button to create a folder, and finally there is a button to save the image, save the cropped image. So I just shown you in the demo. So these three things are in the UI, I would say, in the Tkinter UI. Okay. And also basically whenever you are going to add a new person, is going to increment the number. So person 1 RJ, person 2 XYZ, person face arc, in this way is going to increment. Okay, so this is that thing is checking. This is capturing this is basically counting the FPS, creating the face folder. This code is basically saving the face, saving the crop face. Okay, this code is doing it. Okay. And how is saving the crop face? So like I already mentioned, dlib frontal face detector is basically detecting the face. From that we are getting the square rectangle, and we are just basically copying that part into a small size image. Okay, so in this way we are getting the cropped image of our face. You can read the code, you will understand it. Very simple code it is. And okay, another thing is, if you want higher resolution images, you can change this thing. So for now it's 640 by 480. Okay, but if you need, you can change it. Next, but I don't recommend using a higher frame rate if you don't have a very powerful system. Okay, because the more bigger the frame will be, it will take some time to process it. Finally, in the process, it is just the same. So like I mentioned, this part is just for so only the frontal face detector is getting used. So it is detecting the face. It is basically creating that rectangle. And if we click on click on the save button, it is going to save that face in a folder. So this is all this particular code is doing, nothing else. Okay. Okay. Now, still now there is no deep learning. Now feature extraction to CSV. Here we have the part where what we have is, here this code is going to convert all those images we have saved previously, and from those images is going to create those 128D face descriptors, which I called as face arrays. Now, how is doing this? Now here we are using three things. One is the get frontal face detector, which is basically which detects the face we used in the previous code also. Then there is the face landmark predictor, which is dlib.face predictor, and here we are using that data which you have downloaded from the Google Drive, shape predictor 68 face landmarks. What it does, let me show you in an image. So basically, if we pass an image in this model, it's going to give us these points. So coordinates of this point. So this is our face. If you can see the eyes, the nose, the lips, the chin, everything. So basically this model, whenever we pass a face to it, is going to give us coordinates of all these 68 points. Okay. So this is basically a deep learning based model. Okay. And it's going to give us the points. So here using this predictor, we are going to get the points. And there is this face reco model, which is the face recognition model version 1. And for that we are using another file, which is dlib face recognition ResNet model version 1. That this model also, this data also you have downloaded from the Google Drive. Okay. Now this model is responsible for creating the 128D face descriptor. How it creates? Basically, what is a face descriptor or face feature? Your face feature are basically different facial features, basically the relative positions. That is the mainly the face descriptor. Okay, so maybe your nose, maybe your chin or something like that. There are some relative position. There is some absolute relative positioning, and that is basically the face descriptors. I'm not going in very detail of this face descriptor thing, but if you want to know more, there is a paper which is FaceNet. Okay, this is written by Google developers. You can read it. You will understand what a face descriptor is, and basically how face descriptor works and how basically it is calculating those stuffs. You can read it. But at the end of the day, what is this? It's an array where you have numerical values. That is it. That is the face descriptor. But this is a very unique array using which you can, I will not say uniquely identify, but yeah, mostly you can uniquely identify a person. Okay. Now, as it's an array, it's numerical values. Now, two different person. Listen, my face. From my face, I got this array, and from SRK's face or someone else's face, we got an array. Now values of these two array will vary. Okay, so we can actually find out a distance between two arrays. Okay, now based on a distance, so if you take two pictures of my face and you take the face descriptor, the distance will be very less. Compare whenever you will take some other face and you will compare the face, the overall distance will be more. Okay, so I'll show you how you are basically calculating the distance, but this is the whole concept. So from face we are getting the different points, coordinates. From that we are getting, from that using that coordinates we are going to get the ResNet. From the ResNet model we are going to get a face descriptors, and by comparing two face descriptors we are going to get the distance, and based on that distance we can say, yeah, these two faces are same and these two faces are not same, or even not same, we can say these two faces are similar. Same is not a very good word. These two faces are similar and these two faces are not similar. Okay. Okay, now you see basically this function is going to return that 128D features. As you can see, it's very simple. Basically, it is from the using the predictor, it is getting the points, so the coordinates of the different points, and then it is passing that image and the points to the face recognition model, and from there it is getting the descriptor. And there is also another thing. Let's say we have multiple faces of a single person. So like in the example we saw, I just took 4 images. Then what will happen? So for 4 images, we are going to get 4 arrays. Now we are going to take the mean of those 4 arrays. We are going to take the mean. And then finally, we have a single array only. So remember, in the features file, features CSV file, we are going to only, for a single person, we are going to have a single array. How? By calculating mean of all the arrays we got from all the images, we are going to get a single array. And that array will represent that person. Okay. So this is almost about this file. So basically this file, what is doing is it's going to take the images from these folders, and for every person is going to create a face descriptor. Okay, and if we have multiple images, it's going to take the mean. So if you go features all CSV, you'll see for origin it says a single array, for SRK is a single array. It's 128D array. Okay. So this is how this file is working, this feature extraction to CSV. Finally, we have the attendance taker. This is little complicated file, I would say. A hell lot of things are there, but don't worry, most of the things are simple. I'll explain you the important things. So there is a lot of GUI based things. You don't need to be bothered with those stuffs, but mainly the conceptual part I'll tell you. So get face database. So what is doing is basically from the face database you can get the list. Okay, like what persons are available and what not. So, and then there is this update FPS is going to change the FPS and show on the screen, nothing special. Then there is this centroid tracker. What is centroid tracker is? Centroid tracker is basically when you have the face, it has a centroid. So centroid tracker is going to track the centroid of your face. And why we need it, I'll tell you why we need it. Then we have the draw note, which is basically pasting the FPS data and different data on the screen, nothing special. Attendance. What attendance is doing? Attendance is basically connecting to the SQL app where we have stored the different data, stored the name with the time. And basically attendance, whenever we got some attendance, is going to use some SQL queries to basically here we're using SQLite, so it will write some SQL queries to put the data. Okay, and also another thing which will happen, that thing is not doing, another thing it will do is whenever it will detect a face, it will check if that person is already available in a database, because I mentioned that it's going to only store the first occurrence of the person. So if the person already exists in a database, we are not going to add that person again. You can change this part. Maybe you can allow multiple occurrences also. You just have to change this condition. So if existing entry, then you don't add it. So in that case, you just remove this part and you for every entry you add it. No problem in that. Okay, you can do it. But yeah, in that case, obviously you will have duplicate entries. So a digit multiple times will occur. Okay. Yeah. Next we have the process, which is the main file, I'd say here. So what is happening in the process, what we are doing. So I'll explain you this part, not from the code. So first I'll explain you in detail what is happening. So what's happening whenever a person is coming, it is trying to detect the face. If it's got a face, then what will happen? It is going to use that face predictor to get the landmarks. And once it's get a face predictor, it's going to get a 128D array, feature array. Okay, now it has an array. Now what it will do, it is going to compare that array with all previous entries one by one. Is going to compare, is going to get the distances. Now here we are getting the equilibrium distance. Okay, now all the equilibrium distance will store. Now it will find the minimal one. Now there is a threshold, which is in my case I have put it 0.4. You can change it. So if the minimal distance it is lesser than 0.4, that means we will say that yes, these two faces are very similar, and we are say that yeah, this person is that person. Okay, that is the whole concept. So just you find out equilibrium distance from the current phase with all the recorded phases of the equilibrium distance between the 128D feature array, and then based on the distance, if it's less than threshold and it's the minimal one, then you say yeah, this person is that person. That's the overall concept. Now that's centroid thing, centroid tracking. Centroid tracking, what it is doing, so let's say in current frame my face is here and it's a reject. Now if in the next FPS I just shift my face little bit, now will it again do the whole thing, like the whole computing the shape predictor thing and then the 128D array? If it does it in every frame, then we are not going to get a very high FPS. And what will happen? What will happen is that our app will not be in real time, so it will be very laggy. So what centroid tracking is doing is, centroid tracking basically is tracking the centroid, and we are also checking that if in current frame there are two per person and in the next frame we also have 2 person, then we will check that in the last frame we know where the centroid of the faces were. In the current frame we'll again check where the current face centroids are there. We will find a distance between the centroids and so let's say Arijit centroid is here now. In the next frame I will check which centroid is nearest to Arijit centroid, and that centroid I'm going to say hey, this is also Arijit. Okay, if the number of person in the frame are same, also there is an interval. So what is the name of the interval? Let me check. So yes, here you can see self.reclassify interval. So reclassify interval means there is an interval we are given so that if the number of person are same in this frame and the next frame, and basically no new person has arrived or person has decreased, so number of person are same, in that case there is a reclassify interval, which means that in this interval I'm not again going to check the faces and I'll compare it. I'll not do that, because I just explained that if we do it in every frame the app will get slow. So in reclassify interval we are not going to compare the faces, okay, if the number of persons are same in the frame. So once the reclassify interval is it's more than that, then only again we will check it. And now if a new person comes, so let's say there are 2 person and then a third person come or 1 person went, in that case again we will check immediately that hey, who is this person. So this is just to speed up the app, nothing else. So if the number of person are same in this frame and the next frame, and obviously within these 2 frames the reclassify interval is more than that, so I'll not again going to do the whole thing, the predictor and those things I'll not do. I'll say okay, this centroid, the minimal centroid is this, so Arijit, this is also Arijit, and XYZ, this is also XYZ. And once the reclassify interval is done, I'll again check it, and if a new person comes or 1 person decreases, then immediately I'll check okay, who this person is. Okay, this is just to speed up it. Okay, you can go through the code, you will understand it, but this is the overall concept. This is what it's doing, and that this reclassified thing is just to speed up the app, nothing else. Okay, so this is mostly all of it. I think there are a lot of things here you can read, but this is the overall concept what it's doing. Okay, and whenever it is getting no face, is saying over there is no face, simple as that. Okay, and yes, and whenever it is getting a face, like I said, it's going to compare, and based on that it's going to check that yeah, this is the person. So in that case it's going to mark the attendance. That's it. So this is what this code is doing. And finally we have the app.py, very simple Flux app. So it's just taking the data from database, you are giving it a date, it is writing some query, and based on the date it is showing you a table. Very simple, nothing else. Okay, so this is how this whole thing is working. Now as you know, like I explained you the code, now I'll show you how to run it in the Raspberry Pi. So let me open the Pi. Here is the BNC. So I already have cloned it, but for you, I can show it to you again, but I think I'll just tell you the commands. So it's simple, is you just have to do git clone, then you put the GitHub repo link, it will get downloaded. Okay, next you go inside the file, face recognition, and there you have to download the data file, put it here. If you do so, how you can do it, you can simply open the link in this browser also, or you can use FileZilla. So there is a video in my channel on FileZilla, how to use transfer files between the host system and the Raspberry Pi. You can check that video in my channel. So you have to transfer the data folder in this repo. Okay, and so I already have used it, and I think few entries are there, so I'll just delete the entries. So I'll just yes, so this is how it will look like. Okay, now coming to the installation, one thing very important here, I'm using Raspberry Pi 64-bit. Don't use 32-bit. In 32-bit, installing dlib is a headache, installing OpenCV is a headache, at least for now. So I'm using 64-bit bullseye. Use that. To install OpenCV is just pip install Python OpenCV. Okay, sorry, not Python OpenCV, I think it's OpenCV Python. Okay, and for dlib it's pip install dlib. Okay, for NumPy it's pip install NumPy. For scikit-image it's pip install scikit-image. So this is as simple as it. No, nothing so there is no problem. But compared to 32-bit, in 32-bit you have to install OpenCV, a lot of things are there. Even for dlib it will take a lot of time. 64-bit, it will not, dlib will take around 15 minutes, OpenCV will take 5 to 10 minutes, and remaining things just few seconds it will take. So installation very easy. Now I'll run in Raspberry Pi and I'll show you. So I'll just open the Pi, I'll go to my desktop, and then from there I'll go to that face recognition folder. I have this file, so I'll simply going to call this get faces. This is just to show you the speed. So here I'm using this HP camera, so I'll just put this camera here. Obviously the quality is not as good as the Mac camera, but yeah, it is going to work, I hope. I just need, yes, okay, little bit up. Okay, it's not still working. Yeah, I think, okay, I need to put it. Yes, so yeah, so here I am going to create a window, and here I'll show you even with a single image it works. So let's say Arijit. Okay, I give it a name Arijit, and I give it input, so it is going to create a folder for me. Now here light is very less, that's the problem actually, but I'll just save the face. I'll take okay, for us, let's check with a single face how it's working. Okay, so I'll just take a single face and I'll just close it. Now I'm going to run the what is called feature extraction. So feature extraction file I run, it's going to basically, yes, so CSV file will generate. Next I'll run the python attendance.py, attendance-taker.py. So yes, as you can see, it is rejecting my faces Arijit. Okay. Okay. So this is under PSPC 7. So not that different. So in Mac, I think we are getting 9, 10. Here we are getting 7. So still it's not bad if you see, like, if you see it's not that laggy. Obviously there is some lag, obviously it's Raspberry Pi, but not that laggy. Okay. So this is how it's basically working. Okay. So yes, I think so. Yeah, that's mostly all. Now, like I mentioned, all the files you will get here, the drive link you will get here. And if you want to know more about the facial, that descriptor thing, that is the main face recognition part of this video. You read this paper. I'll put the link of this paper in the description. Read it. It's a very good paper. Read it. And I think that's it. Okay, so if you have any specific query regarding to this video, you just let me know. Okay guys, so I hope you have learned something from this video. So in that case, please hit the like button and subscribe to the channel so that we can make more contents like this. And thanks for watching the video, and very more videos like this are coming. So stay tuned, and I'll see you in the very next video.